Today's lesson is Workplace and Apprenticeship 30.5, Transformations, and today we're going to look specifically at rotation. This little chart is very handy in figuring out what your new coordinates would be when you're rotating around the origin. So we start with a 90-degree rotation. If you take your original pattern for your original point, so X and Y, we're going to try 2 and 1 point. And we are going to rotate it 90 degrees. So our new pattern means that we're going to take our X, move it to the back place in our coordinate point, and we're going to make it negative. So that means we're going to take our X, make it negative, and put it in the back of our coordinate point, and the Y moves to the front. So our new point is actually 1 and negative 2. If we do a 180-degree rotation, same point, this actually makes it easier. If we started off in coordinate 1, we would be in coordinate plane number 3, which just means that they're both negative. So all we do is take the X and make it negative, take the Y and make it negative, but leave it in the same place. 270-degree. Okay, so 270, we're moving clockwise. So you're moving from here all the way around. It's actually the same as a 90-degree counterclockwise. So 90 degrees backwards would be the same quadrant. So we'd start off with 2 and 1. And you are now going to take the Y, make it negative, and put it in the front, and just put your X in the back. So let's see what this looks like on a grid. So we have the 4 following points on this rectangle. We're going to rotate the rectangle 90 degrees. Now we're going to do the best we can. This is going to rotate here. Your rectangle is going to move from being horizontal to vertical. So it's going to move as well as, so rotating it would go down to here. Okay? So it would rotate from this position to the red position. Your A would go from 2 and 1 to 1 and negative 2. B would go from 5 and 1 to 1 and negative 5. Remember, you're going to just make the X negative and put it in the back. This one will be 3 and negative 5. And D will be 3 and negative 2. So let's see if that worked. So 1 and negative 2 is A prime. 1 and negative 5 is B prime. 3 and 5 is going to be C prime. And 3 and this is D prime, and this is C prime. All right, if I rotated the same point 180 degrees, this square rectangle would rotate again, and it would move over to here. One more. Oops, sorry. Right there. Okay. Notice that it's exactly like a 180 rotation. So 180 degree would be the same coordinates but negative. All right, I'm going to move to the next slide because it will be easier to show the 3 movements. So the third rotation would then, this is 270 degree rotation. Originally we had the following points. And the pattern says when you do a rotation that it's now going to be negative Y in the front and X in the back. So it's going to be negative 1, 2. This is going to be A triple prime because we moved it 3 times. B triple prime is negative 1 and 5. C negative 3 and 5, and D is negative 3 and 2. Okay? So our points would then be C, B, A, and D when we rotate it all the way around. All right, we're going to design a snowflake sew-on patch for our local ski hill to use on its uniforms. The first part of the snowflake patch is shown above. So right through the center of this snowflake is the y-axis, and we are going to rotate this piece of the snowflake 90, 180, and 270 about the origin right there. Okay, the original coordinates are here, and the first thing that question asks is, what are the coordinates for the labeled vertices after it's been rotated 180 degrees? Well, 180 is easy. X and Y coordinates stay the same, they just become negative. Now remember, if you started off with a negative coordinate, they would then become positive. So the sign just changes the same. So for example, A is negative 1 and 4, so now A prime is going to be 1 and negative 4. So the sign of each number changes, but it doesn't change positions. Okay, so you're going to try and rotate 90, 180, and 270, and we're just going to do a couple of the points with you, and then I'll show you what the answer is as well. So if I did 180, it would actually go down here. 1, 2, 3, 4, 1, 2, 3, 4, 2 over 2, so it would go like this. 1 over 3, 1 over 1. Okay, so this is about what it would look like if I did it correctly. Okay, so your snowflake is going to go here. All right, that would be a 180-degree rotation, and you could figure out all the coordinate points. I'll show you the answer in just a second. Okay, 90 degrees is going to go over here. So what, let's change colors. What would 90 degrees look like? Well, you take, remember to do a 90 degrees, your X becomes negative and moves to the back, and the Y goes to the front. So our 90-degree points are going to be 1 and 4. So the X is already negative, so we change a negative, and a negative becomes positive. It's going to be positive 1 and 4. And it's going to be 6 and 3. It's going to be 7 and 2, 6 and 1. And if we plot those points, that's where they're going to go. So 1, 2, 3, 4, and 1 is going to be A prime. Okay? And then we would go with our shape from there. So it would kind of look like this. Okay? So you could figure out each point and then plot them on there. If you were going to do a 270, so we're kind of running out of space here, but let's do these last couple of points as 270. A 270 rotation means that the Y, you change the sign of the Y and put it in the front, and the X is positive, or stays the same and goes to the back. So a 270 would mean this was negative 6 and 3, and this one would be negative 4 and 1. Okay, so negative 6 and 3, 1, 2, 3, 4, 5, 6, 1, 2, 3. This would be point I at a 270 degree. 7J would be 1, 2, 3, 4, and 1. Okay, and those actually would connect up afterwards. All right, so that is how you would do the rotation. Oh, just one more point. Page 231 of your workbook also does a good explanation of how to switch the points for different coordinates. So the answer and all the coordinates are here. This answer is 90 degrees. And this one is 270-degree rotation, I believe. No, this bottom one right here down to here, that would be the 270. Okay, and the 180 is pretty simple. 180 is just switching the two signs, or changing the signs. Here's an activity you can try. This impeller is a part of a machine that rotates to move fluid or air. The impeller blades are positioned around a central hub. Wesley is doing some maintenance on the impeller blades from an industrial fan, and they're saying the tenants of the building report poor circulation and a grinding noise when the fan is on. So first thing I want you to do is list the ordered pairs of each of the four vertices of the impeller blades. So the vertices here, what is the coordinate of that point? So that would be 0 and 1, 2, 3, 4, 5, 6, 7, 8. This one would be 1, 2, 3, 4, 5, 6, and 1, 4, 5, 6, 6 and 6. Okay, and I will put up the answers on the next slide. Which blade is out of alignment? And explain how you know. So I'd take a look at the different blades and see if you can figure out which one is not a rotation of the other blades. The answer is D. D should have the same digits in its ordered pairs as H, because D to H is 180 degree rotation. So H point is 1, 2, 3, 4, 5, 6, negative 6, and 1, 2, 3, 4, 5, 6. So this one should be at 6 and negative 6. It should be, and it is not. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. It's actually at 5 and negative 7. So this blade D is out of alignment. Which blade is a 180 degrees clockwise rotation of A? So if we look at A, 180 creates a straight line. So E would be the 180 degree rotation. Which blade is 270 rotation of H? Well, if we're at H and I go 270, it would put us the same 270, counterclockwise is the same as 90 degrees clockwise. So 90 degrees clockwise would be B. Which blade is a 90 degree counterclockwise rotation of H? So 90 degrees counterclockwise is this way, which is the same as 270 clockwise. So you're looking for F from H, 90 degrees counterclockwise is F. And what do you notice about the coordinates of blades identified in B and C? You'll notice that when you do a 180 degree rotation, the coordinates of B and are blades B and F, and they have the same digits but opposite signs. So I'm going to put up the answers so you can take a look at those, but you should be able to look at a picture and determine how far they've rotated various pieces of that picture. We're going to move on to a few examples of scale factor or dilation. Jiwoo is an artist who makes candles, and she wants to make 3 proportional pillars. The medium-sized candle is 9 centimeters wide and 18 centimeters tall. The smallest candle is a dilation of the mid-size by a scale factor of 2/3. So how big, wide and high, is the smallest candle? So 9 times 2/3 equals, and 18 times 2/3 equals. So this is going to be centimeters wide and centimeters tall. Remember, when you're multiplying by a fraction, you multiply straight across. Now, there is no denominator, but you certainly can put 1 over underneath any whole number to make it a fraction. 9 times 2 is 18 divided by 3, which then reduced to 6 centimeters. 18 times 2 is 36 over 3, which then reduces to 12 centimeters tall. Jiwoo has designed a special set of 2-wick candles. The first is 12 centimeters wide, 8 centimeters deep, and 10 centimeters tall. The second is 15 centimeters wide, 10 centimeters deep, and 12 centimeters tall. Is the second candle a dilation of the first? So what we have to do is actually compare the scale factors of each dimension and see if they are the same. If they are the same, then they are a dilation of each other. So the first one we're going to call the original, and so the second one is 15 centimeters deep. So it's always scale over original to figure out the scale factor. So we have 15 over 12. So this is wide. When we divide that out, we get 1.25. Deep is 10 over 8. So 10 over 8, and that's 1.25. And the third is the length, and it's going to be 12 over 10 for tall, sorry. Over 10, which is 1.2. These are not identical. These two are, but the third one is not. So no, the second candle is not a dilation of the first. All the scale factors have to be identical for them to be dilations. I'd like you to build your skills, page 232, 236, questions 13 to 18. When you've checked those answers, move on to practice your skills, page 237, questions 1 to 4, as well as 2 additional questions. Question 4, you're going to be translating that and moving it, and the answers. And a scale factor question about scale drawing, or scale models of trains, and the answer.